Well, students, you have finished all the quizzes, and therefore I'm sure you must have tried all the problems and also got most of the problems successfully. Let us quickly go through the problems in this session. The first problem is on the effective interest rate in a compound interest scheme. The problem asks to derive the formula for the effective interest rate in a compound interest scheme. If you recall, what is the effective interest rate? Suppose you are given interest rate R per annum and you have the compound interest scheme, then actually the interest obtained will be slightly more than what is specified as the interest rate, right? Because of the compounding nature of the interest scheme. Therefore, what is exactly the interest that is obtained in the investment is what is called the effective interest rate. Let us derive the formula now. Let P of 0 be the principal invested and P of capital T be the amount that is obtained finally. Then we can write P of T as P of 0 into 1 plus R capital T divided by N, the whole power N, where T is the maturity time and N is the frequency of the compounding. Now, what is the effective interest rate? Effective interest rate, denoted by RE, is nothing but P of T minus P of 0 divided by P of 0, right? Now, put this value into P of T here, and that will give you finally the expression for the effective interest rate that can be simplified to the form 1 by T into 1 plus RT by N, the whole power N minus 1. And this is the required formula for the effective interest rate. Problem number 2 says that in the example 2.1.9, if Mrs. Sahana deposits 100 rupees on 31st of December 2021, then find the cash flow in her account. So this is about the cash flow from the point of view of the account of a person. Let's recall what is example 2.1.9. The example says that Mrs. Sahana created bank savings account on 1st January 2021 and the bank gives 4% per annum with a quarterly interest payment. She initially deposited 100 rupees in the account and now we want to derive the cash flow in the account. That is the problem. So the cash flow in the account as per the example is given like this. And now Mrs. Sahana deposited another 100 rupees in the account on the 31st of December. Remember, this happened in 1st Jan 2021 and the interest is put quarterly. Therefore, on April 1st, you got this, and then July 1st or maybe June 30th, you got this, and then you have October 1st, you got this, and January 1st, you got this, and one day before you got this one also. So 100. So on January 1st, you will have 101 rupees 303. So this is the account. So therefore, this onwards, the cash flow will change, right? Let us write the new cash flow. X is equal to 100, 1, 1.01, 1.0201, and from now onwards, the cash flow changes. Since Sahana deposited 100 rupees, now you will have 101 rupees 0303, that is 100 plus this number, and now onwards this entire cash flows will change because you are compounding this amount. Therefore, we will have 2.0406 is the next cash flow, and then you have 2.0610, and 2.0816, and finally you have 2.1024 is the amount. And at the end of 2022, the total amount accumulated in the savings scheme is 212 rupees 35 paise. The third question is about how to interpret the cash flow stream. We are given a cash flow stream like this, and we are given that the transaction happened every quarter. Okay, so therefore, this is the first quarter, second quarter, third quarter, and fourth quarter. So you can see that initially there was an amount which went out of this cash flow, and then the first, second, third, and fourth quarter, the money eventually came into the cash flow. So find whether it is a cash flow stream of a deposit received or a loan given by the bank. Since X naught is negative, that is the first entry is negative, the initial cash flow is an outflow, right? Therefore, it shows that it is a cash flow stream for loan. Okay, it means somebody gave loan and therefore the money went out, and then they received the interest every quarter, and at the end of first year they got the interest as well as the principal amount. Okay, so this can be viewed also as a bond, cash flow stream for a bond. You can see that the bank gave a loan at the rate of 3% per annum and collected the interest at a simple interest basis, right? So all this can be inferred from the cash flow itself. The next question is on the recurring deposit. I think this question is given in quiz 1, and the marking scheme has a solution for this. So I hope you all are familiar with this. So let's not discuss this problem. Let's go to the next problem. The fifth problem is find the fair price for the ordinary annuity given by 0, 50, 50, 50 if the prevailing interest rate is R is equal to 0.08 per annum. The fair price of the ordinary annuity is basically the present value of the given cash flow with compounding annual interest rate of 0.08. See, in the problem, frequency is not given explicitly. So we take it to be the annual payment and for the period of 3 years. With this, we get the fair price as PV of X is equal to 50 divided by 1.08. The first term is 0, so I'm not writing it. 50 by 1.08 the whole square plus 50 by 1.08 the whole cube, that is approximately equal to 128.8548. The next question is to find the net present value of the cash flow stream given by minus 10, 2, 3, 5, and 2 if the prevailing interest rate is 2% per period. Okay, so here there are two things that you have to note. One is you are asked to find the net present value of the cash flow, and second thing is you are asked to find you are given the interest rate per period. Okay, so why we are asked to find the net present value and what is the extra that we have to do in order to get the net present value? Well, we don't need to do anything, because since the first term given, that is x naught, is non-zero, you find simply the present value that itself is called the net present value. The present value of a cash flow is called a net present value if x naught is not equal to 0, right? So therefore you simply find the present value, that will be nothing but the net present value. The present value of the cash flow stream X is x naught, which is minus 10, plus 2 by 1 plus R. So since it is a per period rate, therefore 1 plus R, this is 1.02 plus 3 by 1.02 square plus 5 by 1.02 cube plus 2 by 1.02 power That is approximately equal to 1.4036. The next question is, show that there always exists IRR for an annuity with frequency n equal to 2. If you recall, what is IRR? IRR is the interest rate of return. An annuity with frequency 2 can be written as x naught comma x comma x, and hence the IRR equation is a quadratic equation of the form x rho square plus x rho plus x naught equal to 0, right? That gives us rho is equal to minus x plus or minus root of x square minus 4x naught into x divided by 2x, right? In annuity, x naught and x, they are of opposite sign, right? Therefore, x naught and x, these two are of opposite sign, and therefore this term is less than 0, and hence this becomes a plus sign. That always makes this square root term to be positive, and hence this row is a real number. That is how the IRR exists always. The next question is, consider a coupon bond with cash flow given like this for some real number C greater than 0, where each coupon amount is for 1 year and paid M times a year, right? The yield, the important point is that the yield is given to be the same as the coupon rate. That is, R is equal to C by Pn is given to us. If the compound scheme for the frequency M is considered, okay, then show that the issue price, what is P naught? P naught is nothing but the issue price. That is the price of the bond at time t equal to 0. The issue price, therefore, is equal to the face value. That is what we are supposed to show. When it happens, if it happens when your yield at the initial time coincides with the coupon rate. How to show this? Recall, P naught is nothing but the present value of the entire cash flow B. Okay. Therefore, this is given by Pn by 1 plus R by M, because the frequency of coupon payment is M, to the power of M into N, because there are N years of maturity, right? This is implicitly given to us, plus the coupons are discounted like this. K is equal to 1 to M N C by M divided by 1 plus R by M to the power of K. Okay. Now what you do is take lambda equal to 1 by 1 plus R by M and use the elementary formula 1 plus lambda square up to lambda j is equal to 1 minus lambda to the power of j plus 1 divided by 1 minus lambda. Okay. So if you take 1 by 1 plus R by N as lambda, you can see that these all can be written as is equal to K equal to 1. So C by M lambda plus C by M lambda square, like that it goes, right? Plus C by M lambda to the power of Mn. So use this elementary formula here, and you can write P naught as, that is this term, can be written as Pn divided by 1 plus R by M power Mn. There is no change in this term, but the next term, you can write it like this: 1 minus 1 by 1 plus R by M, the whole power M into N. Okay. So that can be rewritten. Okay. Why? Because you are given R is equal to C by Pn, right? That is given in the question itself here, that I am using. now in this, and that gives me Pn by 1 plus R by M to the power of Mn plus Pn, because C by Pn, so Pn goes to C get cancelled, and you have 1 minus 1 by 1 plus R by M to the power of Mn, right? So now you can see that this simplifies to Pn. Next question has two parts. We are asked to calculate the Macaulay duration for a 4-year annual coupon bond with coupon rate 6% and the yield is 5.5%. Since the coupon is 6%, let us take the principal amount to be 100. Then the cash flow C is given by, let's take the first one as 0, 6, 6, 6. So because 4 years, the final, that is the 4th year, is principal plus the coupon. So that's the cash flow. So let us write all the data in the table form. The Macaulay duration calculation is shown in this table. The time in year is given like this. There are 4 years, therefore you have 1, 2, 3, and 4, and I have written the cash flow in this way. Now PV of the first term is nothing but, so this is nothing but 6 by 1 plus 0.055. Why? Because yield is given by 5.5%. So that gives us 5.6872. And similarly, the second one is given by 6 by 1.055, the whole square. And similarly, the third one is given by 6 by 1.055, the whole cube. And the last one is given by 106 by 1.055, the whole power 4. Okay, so that gives us the present value of each cash flow individually. Now how will you find weight? Weight is nothing but PV of CT divided by the PV. What is PV? PV of the entire cash flow, C, right? So entire cash flow is the sum of all this, that is 101.7526. Therefore, this divided by this gives us this one, 0.0559, that is 5.6872 divided by 101.7526 gives us the first weight. Similarly, the second one divided by PV gives us the second weight, and so on. Obviously, if you add them all, you will get 1. And what is this one? This is 1 into, that is T into WT. Okay, and you add all this, that precisely gives you the Macaulay duration. The second part of the problem can be done in a similar way. The second part asks us to find the Macaulay duration of a 2-year semi-annual coupon bond. 4% as the coupon rate and yield as 4.8, compounded semi-annually, right? So either you can calculate semi-annual or can calculate with T equal to 1, 2, 3, 4, like how I have done here, and you can find it. And finally, the Macaulay duration, which you get like this, will be divided by 2. 3.8829 divided by 2, that gives me 1.9415 approximately as the Macaulay duration. Okay, or you can take T is equal to 0.51, 1.52, and then you make this table directly to get this number. Okay, so any way you can do, it's not a problem. The next problem is to find the formula for the forward rate FJK. Remember, FJK is the notation for the forward interest rate per annum between the year j and the year k, that is the jth year and the kth year. Let me again do it when k is equal to 2 and j is equal to 1. In this case, the relation between the spot and the forward rate can be written as 1 plus S1 by M. Remember, I am taking J is equal to 1 and K is equal to 2. You can do it for the general case. So we are assuming that there are M period in a year. That is why we are dividing S1 by M, because S1 is an annual spot rate. And since we are giving M period per year, therefore the spot rate for the first year is like this. Then in the second year, you go for a forward rate, which is from year 1 to 2, and that is divided into m parts to the power of m. On the other side, we have the 2-year spot rate, that is given by 1 plus S2 by m, because it is also divided into m parts for the compounding. Therefore, you have m, and that is for 2 years. Therefore, 2m you will have. Now, this can be written as 1 plus F12 by m, the whole power m, is equal to 1 plus S2 by m, the whole power m, 2m divided by 1 plus S1 by m to the power of m. So this can be simplified further to get the formula for F12 as m times 1 plus S2 by m. See, we are taking a mth root, therefore m goes off, you have only square and divided by 1 plus S1 by m, and then a minus 1 here. So that is the formula. Remember, it is for j equal to 1 and k equal to 2. Now you can generalize it to any j and k. So therefore this part is done, and the same idea will go with continuous compounding scheme also. I leave it to you to complete this problem. The next question is on risk neutral probability. We are asked to derive the risk neutral probability in the annual interest rate R is taken to be quarterly compounding scheme. If you recall, in the class, we have derived the risk neutral probability when the interest scheme was continuous compounding scheme, right? So the same we have to do here for discrete compounding with quarterly frequency. If you recall, we have this equation. Expectation of S1. S1 is a random variable, that is the stock price at time, say, capital T, and that is given by S0, which is the stock price at time t equal to 0 times u, right? This is your actually your S1 if the stock goes up, and that happens with probability P, plus S0 into D, that is again it is S1 if the stock goes down, and that happens with probability 1 minus P, right? So this is the definition of the expectation. Now, if you recall what we did from the fair game condition, what we have is if you discount this expectation between the time t equal to 0 to t equal to capital T, so this expectation of the stock price, so this you can imagine it as a stock price, that is a value, and that is discounted by a factor, okay? That should be equal to your stock price at t equal to 0, that is S0, right? So this is the condition. Now the question here is, what is this discount factor? That's all is the question. In the class, we have taken this discount factor to be e power minus r t. Why it is so? Because we have done it for continuous compounding. The same it is asked for quarterly compounding scheme, and therefore you have to correspondingly put the discount factor. You know what it is, so I will leave it to you to do that. So once you do it, then you just have to take E of S1 is equal to S0 divided by the discount factor, right? So equivalently here what we got was S1, E of S1 is equal to S0 into E power RT we got in the class, and that we substituted here. Okay, S0 get cancelled. From there you got your P value, and that is what we called as risk neutral probability. Same, you have to put now this value into the equation with an appropriate expression for the discount factor. You know what it is for a quarterly compounding scheme. So I'm just not telling you, but it is very trivial. You put it again, you cancel S0 on both sides, and then find P from there. You will get the answer. I leave it to you to complete it. The only thing you have to do is to put the appropriate expression for the discount factor when the scheme is a quarterly compounding scheme. The next question is, let the price of the stock be governed by log normal distribution with parameters mu and sigma given to you. You have to find the expectation of the stock price for 6 months and the standard deviation of the stock price again for 6 months. This is the question. If you recall, in the class we have derived the general expression for expectation and the standard deviation. They are given by, the expectation is S0 into e to the power of mu plus sigma square by 2 into t, and the variance is given by S0 square e to the power of 2 mu plus sigma square into t into e to the power of sigma square t minus 1. Now what is given to us here? First of all, it is for 6 months. Therefore, we can take t is equal to 1 by 2, right? 6 by 12 it means. So it is 1 by 2. And mu is given by 0.12. Sigma is given by 0.2. So just to plug in these values here, you get the expectation as 1.0725 into S0. In my calculation, please check if this calculation is correct. 0.0232 S0 square. So these are the answers for these questions. The next question is about the probability of the stock going up and down by giving the drift and the volatility, and also the initial price S0, and we are assuming that the stock price is governed by the geometric Brownian motion. I think this question is one of the quiz questions, that is quiz 2, I think. Maybe some numbers are different, but the underlying idea is exactly the same, and the full answer is given in the marking scheme. Therefore, let me not discuss it here. The next question is about finding the risk neutral probability of stock, which is just discussed in the previous example with the prevailing interest rate as 6% per annum. I think it's also a easy numerical question, and the answer is also given. So you can do this. Next question is, in the matching procedure of binomial lattice model with the log normal model, if we take P equal to 1 by 2, what will be the corresponding expression for U and D is the question. If you recall, in the class we have done this matching procedure for binomial lattice model to get U and D. There we got two equations given like this, and we had three unknowns. But what we did is we took D is equal to 1 by U in these equations, and we reduced these two equations with two unknowns. Then we solved these equations to get those two unknowns U and P. That is what we did in the class. Now, instead of giving D like this, we are giving P to be the symmetric probability. So thereby what you will do, you will put 1 by 2 here, and this will become therefore 1 by 2. And similarly, this term will become 1 by 4, right? Now again, you got two equations with two unknowns as U and D. From here, you can solve these two equations to get the expressions for u and d, and that is what is asked in the question. I think you have u is equal to e to the power of mu delta t plus sigma root delta t is what we get the expression for u, and d is given by e to the power of mu delta t minus sigma root delta t.